Assalamu alaikum, students and friends. In today's episode, we bring back a revised excerpt of a past upload on carbon type resistors. How do we read the ohmic value of a resistor that is color coded? To find out, just stick around, watch and learn. The question is, give the range of the ohmic values of each of the color-coded resistors in figures 1 to 3. The four color bands in figure 1 are red, green, red, and gold. In figure 2, the 5 color bands are brown, black, black, brown, and red. While in figure 3, the 6 color bands are red, violet, yellow, black, red, and brown. Three given resistors that we are discussing here are the carbon type resistors with color bands printed on the outside coating. For our first resistor, R1, shown in the drawing, the first three stripes are pretty close to one another, while the fourth stripe is a bit far from the first three stripes. Each color or color stripe has a corresponding digit equivalent, okay, such as 0 for black, 1 for brown. Notice that black, being the darkest color, has the lowest digit 0, and brown, which is less dark than black, is assigned the next low digit 1. Gray and white, on the other hand, which are the lightest colors, are assigned the highest digits 8 and 9, respectively. The digits 2 to 7 are assigned to colors of the rainbow except indigo, right? So red is equivalent to the digit 2, orange is 3, yellow is 4, green is 5, blue is 6, and violet is 7. Moreover, we also emphasize that the last stripe for this 4-band resistor actually represents what we call the level of tolerance. Commonly used are the colors gold and silver. Gold means the level of tolerance is plus minus 5%, and silver corresponds to plus minus 10% tolerance. When there's no fourth band or no fourth stripe, it is understood that the level of tolerance of the resistor is plus minus 20%. So for this particular resistor, right, the first stripe is red or digit 2. The second stripe is green or digit 5. The third stripe is red or digit 2, and the fourth stripe is gold. So its level of tolerance is plus minus 5%. Hence, the equivalent ohmic value for this resistor, we say, is 25 times 10 to the second power ohms, right? So the third stripe here, which is red, corresponding to the digit 2, or as a multiplier, that means that is uh, times 10 to the second power or times 100, right? That's why uh, when written in its normal way, we say that R1 is equal to 2,375 ohms, all right? Because we take 5%, all right? 5% of 2,500 ohms is actually 125 ohms, right? So when we subtract 125 ohms from 2,500 ohms, that's equivalent to 2,375 ohms as the lower limit. While if you're going to add 125 ohms to 2,500 ohms, then we are getting the upper limit, which is 2,625 ohms. That's why the what we call the range values for this particular resistor is from 2,375 ohms up to 2,625 ohms, right? So, what does this range values suggest? Right. Supposing you actually measure the what you call ohmic value of this resistor using a reliable ohmmeter, all right, or a multi-tester, and if the measured value is not within this range, all right, say for example, if the measured ohmic value is less than 2,375 ohms, or perhaps greater than 2,625 ohms, we say that the resistor is defective, or it has a factory defect. Okay, and you are advised not to use this uh, particular resistor anymore. For our second resistor R2, it has 5 bands: brown, black, black, brown, and red. The first 3 significant digits of this particular resistor are 1, 0, and 0, right? And the fourth digit is 1, which uh, serves as the multiplier, right? So unlike the first resistor we discussed earlier, we now have a resistor with 5 color bands, right? We say that this kind of resistor is more precise, right? Because there are now 3 uh, significant digits, like for example, right, brown, black, and another black, all right, are the first uh, 3 significant digits, all right? The fourth digit serves as the multiplier, right? So the ohmic value for this resistor, therefore, okay, is equal to uh, 100 ohms, right? And multiplied by 10, right? Uh, 10 is the corresponding digit for the color stripe brown, right? So that means our multiplier is times 10 raised to the first power ohm, or that's simply times 10 ohms, right? While the last stripe, or the pip stripe here, is color red, all right? Uh, the uh, the last stripe, okay, uh, which indicates the level of tolerance, all right, are usually gold and silver. But for this particular resistor, we have the stripe color red, representing the level of tolerance. And since red corresponds to the digit 2, right? That means the level of tolerance for this particular resistor is plus minus 2%. All right? So, if you're going to express now the range values, right? We say that R2 can range from uh, 1000 ohms plus minus 20 ohms, right? So plus minus 20 ohms, right, is the level of tolerance. Deducting 20 ohms from 1000 ohms gives us the lower limit, right, which is 980 ohms, while adding 20 ohms to 1000 ohms gives us the upper limit, which is 1020 ohms, right? So this is our final answer to the question for resistor number 2. The third resistor, R3, is a 6 color band resistor consisting of red, violet, yellow, black, red, and brown. And just like resistor R2, right? Um, the first the first 3 color stripes, okay, are the what we call significant digits, while the fourth stripe is the multiplier, right? And the level of tolerance is the pip stripe, right? So, unlike resistor 2, which has also 5 stripes, this one has 6. And the 6th stripe here, right, represents what we call TCR. TCR means the temperature coefficient, all right, of resistance. All right. TCR actually means the rate at which the resistor changes with change in temperature. All right. So, example, if the 6th stripe is the color brown, right, we say that the TCR is 100 parts per million per Kelvin, meaning for every 1 Celsius degree or 1 Kelvin change in temperature, the resistance value changes by 1%. The ohmic value of resistor R3, therefore, is equal to 274 times 10 raised to the 0th power ohms. 2, 7, and 4 being the first 3 stripes corresponding to red, violet, and yellow. And the 4th stripe, right, which serves as the multiplier, is colored black. That means times 10 to the 0th power, or times 1, all right, is our multiplier. And the 5th stripe is red, so the level of tolerance is plus minus 2%. And of course, the TCR, okay, is 100 parts per million per Kelvin. And expressing the range values for R3, we now have 269 ohms up to 279 ohms, right? The 2% of 274 ohms is in fact 5 ohms. So that when 5 ohms is deducted from 274 ohms, we get 269 ohms as the lower limit, while adding 5 ohms to 274 ohms is 279 ohms, being the upper limit. All right? So, we also include the TCR value of 100 parts per million per Kelvin. So this is the complete answer for question number 3. So that concludes our lesson. Okay, mabuhay. Till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.